So, good evening. I'm Doug Roberts, here representing PS21. We're very happy to see so many people for tonight's event with Cameron Wake to hear about climate change and its impact on Portsmouth. PS21, Portsmouth Smart Growth for the 21st Century, presents informational events about planning in Portsmouth. Our topics over the past 2 years have included walkability, downtown parking, public transportation, architecture, housing affordability, and development in Portsmouth's north and west ends. We believe because people care about Portsmouth, they want to learn about how our city is developing and to discuss the opportunities and potential impacts. Before we get started, I would like to thank PS21's season sponsors who help us offer these events free of charge. Piscataqua Savings Bank, Chinburg Properties, Seacoast Rotary Group, and Corway Film Institute. Our supporting sponsors are 3S Art Space, Seacoast Media Group, and The Sound. PS21's next event will be a tactical urbanism project this spring in the West End. It will involve a short-term makeover of part of Islington Street using temporary measures like street striping and landscaping to demonstrate ways to make the street safer, more interesting, and more comfortable. PS21 has received a grant from the New Hampshire Charitable Foundation, and the City of Portsmouth has offered financial and logistical support. We need additional sponsors to fully fund this experimental streetscape project. Please consider becoming one. So video for tonight's event is being recorded by Bill Rogers of Corway Film Institute, and it will be online in the next few days. Portsmouth Community Radio 106.1 FM is also recording the presentation and will rebroadcast it tonight, 11 and at future times. Social media group users can engage during the event through Twitter using @PortsSmart21 and hashtag PS21. Our website, ps21.info, is the best place to find all this information and more. Videos of past presentations are there, and you'll soon find information about a design charrette being planned to follow up on our January affordable housing event. Tonight's speaker, Dr. Cameron Wake, is an internationally recognized climatologist and professor at the University of New Hampshire. He's here to talk about one of the most important issues facing our city and the world, climate change. Cameron leads research programs to assess the impact of climate change in New England. He reconstructs climate change from ice cores recovered on the Tibetan Plateau and the Arctic, and has authored more than 60 papers and reports, including a series detailing the impact of climate change in the Northeast United States. Cameron also directs Carbon Solutions New England, a public-private partnership promoting collective action to achieve clean, secure energy future, and he helps lead the New Hampshire Energy and Climate Collaborative. Everyone has some cards on their seats. If you have comments afterwards, we'd love to hear them. Just write them down and drop them off as you leave. There'll be a question and answer period after Cameron's talk. So thank you, everyone. Here's Cameron Wake.
All right. Thanks for coming out tonight. It's a great crowd. Before we dive in, actually, I just want to take a minute and recognize somebody who's a hero of mine, Josephine Lamprey, sitting right over here. She's my hero for many reasons, but one in particular is that she used to run an oil business, and she heard about climate change and educated herself. and then actually changed her business from a home heating business into a home comfort business, and really began a conversation around the issue of climate change and what we should do about energy efficiency back in 2005 and 2006 with an event at the music hall called This Old Planet Needs a Friend. And that's where I first got to know her, and we have become close friends since that time. So as Doug said, I'm going to talk for about 45 minutes, try and stick to 45 minutes. Then we're going to have a few community members talk about some efforts that are ongoing right now as a way for you to get involved. And then we're going to open it up into a much broader conversation about climate change. And I'll answer any questions that you have, and I'm happy to answer those questions for as long as you have them, especially if somebody buys me a beer once the question period starts. All right, I really want to tell you three things tonight, and I've been saying this for well over the past decade. The first is climate changes. It always has and always will. The only difference today is that there is an extensive and ever-growing body of scientific evidence that shows that humans are the main driver of that change. And once you understand that humans are the main driver, you realize that the future climate is literally in our hands. The climate that our children and grandchildren inherit depends fundamentally on the decisions we make today and over the next decade about how we produce and how we use energy. All right, the second point is that I think climate change is the innovation opportunity of the 21st century. It is going to require all of us to act, from individuals to families to communities to municipalities to states to the country to the entire globe to solve this problem. And we're not going to solve it by doing the same old thing. We're going to have to do things a lot differently. And there's actually a lot of promising opportunity out there, but we're really going to have to invest in that innovation in order to make it happen. And last but not least, climate is a distinct moral issue. And I've really come to this over the course of the past 30 years of studying this topic, because it is those who are most vulnerable who are going to suffer the most. And you can think about that in many different frames, but when I drove over here tonight and emitted carbon dioxide, that carbon dioxide is going to be in the atmosphere for well over 100 years. And so it's changing climate now, and it's going to change climate well into sort of several generations to come. So we get all the benefit, and we're putting the impact on future generations. But it's also the young, the old, and the sick and the poor that are going to suffer the most. And you need look no further than what happened in Hurricane Katrina or Superstorm Sandy to realize that is true in this country, and it's also true around the globe. We are going to be able to adapt in this country, but many other countries around the world are not. So with that frame, I'm going to provide you with charts and graphs. First half is going to be talking about climate change, and the second half I'm going to transition into what I think are sort of a range of potential solutions. All right, so I'm going to argue that climate change is the most important grand challenge that we face because it makes every other grand challenge more difficult or impossible to meet. So you might think that childhood hunger is a grand challenge. Well, it's going to be made more difficult because climate change is going to reduce the amount of food that we can produce, because there's going to be more flooding and there's going to be more heat waves, there's going to be more crops that fail as a result. And this is especially true in the tropics, where the majority of humanity lives. So you might think that national security is the most important grand challenge. Well, the Quadrennial Defense Review that was brought up by the Pentagon clearly states that climate change is going to make it more difficult to secure our nation. In fact, this 80-page report, 10 pages are focused on the issue of climate change. You might think that biodiversity is the most important grand challenge, and preserving that biodiversity, especially in light of the fact that we are now undergoing the 6th major extinction that the Earth has experienced in the last 600 million years since life really blossomed on the planet. It's going to be made more difficult in large part because climate change is already causing those extinctions. And you might think that human health is the most important grand challenge of our time. It's going to be made more difficult. Human health is going to be impacted in a whole range of aspects from climate change, again, from more floods, from more droughts, from the expansion of vector-borne disease, and recent research coming out that shows that big weather disasters have a significant impact on humans' mental health. So that's my frame, that really this is a significant challenge that we have and one that we need to address many of these other significant challenges. I was just doing a little research on what else the Department of Defense has come up with recently since its quadrennial defense review, just to drive home this point about national security. And there were three more recent documents that have come out since the quadrennial defense review. The Climate Change Adaptation Roadmap talks about how climate change is a threat multiplier because it exacerbates many of the challenges we're already dealing with. Report to Congress in July 2015 sees climate change as a present security threat, right? This is not something that's way out in the future. It's happening right now, but it does also pose a long-term risk. And then just recently, Climate Change Adaptation and Resilience Directive, right, which is basically provides a roadmap for how our military is going to respond for at least the next decade. Right? We need to provide the DoD with the resources necessary to assess and manage risks associated with the impact of climate change. So our military apparatus is clearly paying a lot of attention to this. And if there's a fourth take-home message from what I want to say tonight is that we should be taking this issue much more seriously as an entire community than we have in the past. I can't really talk about climate change without talking about some ice core data, as I am an ice core paleoclimatologist. So I'm just going to, this is probably the most data-rich slide that I'm going to have, but this is a seminal record. This is a really famous ice core record from a place called Vostok in Dome Sea in Antarctica. It's an ice core record, and then up there on the left-hand side, you actually see a cross-section of an ice core in cross polars. And you see those nice little hexagonal crystals, and those blobs are actual samples of the atmosphere that are trapped in the ice lattice. Glaciers are wonderful archives. They have, where if you go in the right place, they have this nice horizontal stratigraphy, and when you drill down, you essentially go back in time. We crush that ice, and you can actually look at the trace gas content in those bubbles, and that's what I've plotted here, the carbon dioxide record in blue across the top that's come from that ice core. And then we can also melt the ice itself and look at these things called oxygen isotopes, which give us a measure of how the temperature has changed over time, and that's in the orange on the bottom. And hopefully over the time you've been looking at that record, you begin to see that the changes in carbon dioxide are mimicked by the changes in temperature. High carbon dioxide, warm temperatures. Low carbon dioxide, low temperatures. This data set from Vostok and Dome Sea clearly shows the integrated functioning of the Earth system, right? It is an example of the greenhouse effect at work. I'd also mention, you can see back here, 18,000 years ago, when it was really cold in Antarctica, we had really low carbon dioxide. Life here in New England was very different because there was no life. There was no trees, no forests, no lakes, because the entire region was covered in a mile of ice. Right? So over the course of the last 18,000 years, we have seen dramatic climate change that goes from a huge ice sheet covering the northern half of North America and the northern half of Europe to essentially the climate that we have now. And that happened in a really short period of time with carbon dioxide that went from about 180 parts per million to a little less than 300 parts per million. The other thing you'll note about this graph is that for the last 800,000 years, carbon dioxide has never been higher than 300 parts per million in the atmosphere. So I've changed the axes on you just to sort of pull this down. Enter human beings. We discover fossil fuel. We burn it. It provides us with energy and changes the way our society works. Lots of wonderful things, but there's this byproduct called carbon dioxide. And since we started monitoring carbon dioxide in the atmosphere in 1957, it has gone from about 320 parts per billion to 400 parts per billion. An amount of increase that is equivalent to the shift that we see between an ice age and an interglacial period. With that alone, I can tell you humans are dramatically influencing the climate system. If we keep on relying on fossil fuel as our main source of energy, by the end of this century, we'll end up with carbon dioxide something on the order of 1,000 parts per million, with catastrophic climate change that will completely change our relationship with the Earth. Conversely, if we invest in clean energy and energy efficiency, we might be able to stabilize at 400 and 450 parts per million, which will result in some changes, but changes that if we work really hard, we can adapt to. That's essentially our challenge. That's where we're going, to 1,000, and where we need to be is around 450 to 500. Where's all that carbon dioxide coming from? Well, if you guessed China, you'd be right. So you can see the USA. These are global, countrywide greenhouse gas emissions from 1950 up to 2012. And you can see the USA used to be #1 until 2007 when China surpassed us, and China's growth is just increasing exponentially, and India is not far behind. If you have to boil this problem down to something to its most basic level, is we need to figure out how we power our economy and significantly reduce our greenhouse gas emissions, and then help China and India and Indonesia and Brazil and the rest of the developing world do that. We cannot solve this problem without the globe being completely engaged in this challenge. Coming back to a little bit more to the present, this is a temperature curve come out from the most latest NASA Goddard Institute for Space Studies. So from 1880 to 2015 on the bottom here, you can see end of the Little Ice Age through here. Then we see this big warming with 2015 being by far the warmest year on record. You can see spatially sort of that rate of warming. You can see big spot in Central Asia has warmed up quite a bit. You can see the Arctic has warmed up quite a bit. You'll also notice that the North Atlantic has been cooling. There are some naysayers that point there and say, look, there's no global warming. There's one spot on the Earth that's cooling. But it's actually a projection of a really nasty surprise, a significant change in the overturning circulation in the North Atlantic called the Great Conveyor Belt or thermal haline circulation. I'm not going to go into more detail, but we can talk about nasty surprises more if you ask me about them. A couple of other trends. Arctic sea ice is really important for the Earth's climate system because it essentially reflects incoming solar radiation right back out into space, serves as the northern hemisphere air conditioner. That yellow line around the outside represents the long-term average, but that white area represents where it was in 2012. So we've seen a significant reduction in the Arctic sea ice at the end of the summer. And it's a big deal because when it melts, you actually have dark water underneath it that absorbs lots more solar radiation and serves as a feedback loop that actually speeds up the rate at which the Earth is warming up. So you can we've actually been mapping this since 1979. I show this figure in two ways here to show you how some people serve to cherry pick data. I have seen people say, look, if you look at the sea ice record, end of the summer sea ice extent, and you just look at 2012, 2013, 2014, and 2015, you can see it's recovering. There's nothing to worry about. I have seen this argument made on more than one occasion. However, as a good climatologist, you look at all the data and you can see that there is a significant long-term trend. And in fact, this decrease is happening much more rapidly than scientists predicted it would. And sea ice is likely going to disappear in the Arctic Ocean by the end of the summer. I just heard about a cruise that's doing the Northwest Passage, actually. It's only going to cost you 80,000 pounds, and you can be on board a big cruise ship and go through the Arctic over to Europe later on this summer. I want to take a little bit of time and talk about what I think is sort of the second big nasty surprise. And it's in part embodied in the Greenland ice sheet and in part in the West Antarctic ice sheet, but I'll talk just about Greenland. So here's a picture of Greenland over there. Hopefully you recognize it. And the different colors actually represent the surface velocity of the ice that's actually being measured from synthetic aperture radar. And this is from a series of papers done by Ian Jochen at the University of Washington. So you can see these sort of green colors are slow, but these hot colors down here are really fast-flowing ice. So I'm going to focus here on this glacier called Jakobshavn, which has gotten a lot of attention recently. And you can see on the left-hand side the velocities here, right? We're looking something on the order of 2 to 3, right, kilometers per year that this glacier is moving. This actually shows the change in speed over a 5-year period, 2000, 2001 to 2005, 2006. And you can see the main body of the glacier actually sped up, right, on the order of 1,000 meters per year. Like it almost doubled its velocity. We're not talking about something small here. We're talking about a glacier that's the size of something that would go from Mount Washington down the Merrimack River Valley and into the Atlantic Ocean. So just let me show you this. I know there's a lot of data here, but it's actually really important. We're going from 1990 up to 2014, and each one of these lines represents a different spot on the flow line of a Jakobshavn glacier, right? So you can see back here, the ones in red are going faster, the ones in blue that are up here are going slower, but you can see over time, you can see that from 02, 03 to 07, we sort of had that doubling, And the rate of that velocity of that glacier has also doubled in 2013 and 2014. So Jakobshavn Glacier is dumping way more ice out into the North Atlantic. And as a result, it's also retreating way up here. And this is behavior that has changed dramatically. And when I talk later about our projections in sea level rise, there's a big range in our projections of sea level rise. It's because we don't fundamentally understand the dynamics that are going on here enough to predict them. But it is a real concern. And both, there's 3 big outlet glaciers in Greenland and 2 in Antarctica that are showing this behavior, and we think that they might draw down vast amounts of ice from these glaciers in a very short period of time. And in fact, the people who study this, 2 different papers were published last year that said it could be inevitable that Greenland and West Antarctica ice sheet melt, which is sort of the equivalent of 25 to 35 feet of sea level rise. The big question is by when? So I'm going to skip on the chasing ice video. Maybe we'll show that at the end if we get to it. Another piece of data here is global mean sea level rise. We measure it in tide gauges, but we also measure it from satellites, in this case the Topex and Jason satellites, and this goes back to 1991, and you can see that long-term increase of about 3.3 millimeters per year, just over the course of the past 20 to 30 years. So sea levels are definitely rising. All right, so that's the global picture. See, I'm right on time here. What I want to do is just transition to talk a little bit about what's been happening mostly across New Hampshire. And all of what I'm going to say is available in this series of reports that's available on that website. So you can go and there's much more data that we talk about in those reports. So we've looked at the best available meteorological data that we can get for the state of New Hampshire. And for southern New Hampshire, there's really only 3 stations, Keene, Durham, and New Hampshire. And we looked at all the different records. And I'm showing you the one that shows the greatest amount of change, and it's average annual minimum temperature. You can see a little bit of change here, but really dramatic change starting in 1970. Minimum temperatures, it really means that our night times are warming up much more rapidly. Daytime's not warming up that much, and it's a consistent signal across the region. We're also seeing significant changes in precipitation. This graph, this plot comes out of the National Climate Assessment, and they looked at the biggest 1% of events and how much that amount of rain that fell in that largest event actually changes over time. And you can see the Northeast is a bullseye, right? 71% increase. So if only it was that. It's actually a lot worse than that. When you look at the really biggest events, which we classify here as 4-inch precipitation events, those events that drop 4 inches or more of precipitation. This is from a really good meteorological station in Durham, and this is decadal. This is the number of events per decade. 1963 to 72, we had 1, right? They grew through the decades. From 2003 to 2012, we had 10. Right? That's a 10-fold increase in the number of extreme precipitation events, combined with the fact that the population has tripled. The amount of impervious surface has quadrupled. There's no wonder we're having way more floods today than we had in the past. And that's borne out for the amount of money that New Hampshire asks from the federal government for emergency declarations and declared disasters. Not much back through here, right? The odd event, 2005, 2006, 2007, 2008, again in 11 when we dodged a bullet, mostly because of Irene, a little bit in 12 and a little bit in 2014. Right? So we're seeing the impact of climate change and development on the amount of flooding that's happening across this region. All right, so that's what's happened in the past. I want to talk a little bit about what might happen in the future. And it's a real challenge to figure out what's going to happen in the future with climate because we don't really know what human beings are going to do. So instead of actually providing a prediction, what scientists have done is developed a set of scenarios, plausible storylines on how society might change, not definitely, plausible how it might change, not how it will definitely change. And so one of the ways, so we look at sort of how, what the population is going to do, what our socioeconomic activity is, and then from that we kind of backtrack into what global emissions of greenhouse gases are going to be. And so here you have, there's lots of scenarios that have been developed. I've simplified them here. We have a higher emissions scenario and a lower emissions scenario. This is a scenario where we just keep burning fossil fuels as our main source of energy, and this is the track we are on, no doubt. We're actually above this line right now. This is the emissions scenario where we invest in renewable energy and energy efficiency and power our economy without burning lots of fossil fuels. So we then take those and actually put those global emissions scenarios, and we drive these tools that we have called global climate models to figure out how the climate might change in the future. High emissions, low emissions scenario. What we've added to this, we don't run those global climate models at UNH. They're done at sort of big supercomputers around the world. But we take that and downscale it so we get much finer information so we can better understand what might happen in our particular region. So I'm just going to show you a few results. So here's average summer maximum temperatures across southern New Hampshire under the high emissions and the low emissions scenario. And there's two things that you should be fundamentally aware of in this graph. The first is, by 2050, there's no difference if we follow a high emissions or a low emissions scenario. That amount of warming, right, another 3 to 4, maybe 5 degrees Fahrenheit by the middle of the century, is locked into the system. That is the amount of warming that we are committed to, so we better start figuring out how we're going to adapt to that, right? We're all going to get air conditioners. Conversely, by the end of the century, you see a big difference in whether we follow a low emission or high emission scenario. High emission scenario, you see temperatures go up by 10 to 12 degrees Fahrenheit, which means we have a climate that currently exists in North Carolina, and North Carolina becomes unbearable. Under the low emission scenario, you don't see that much warming than we do sort of out to 2050, right? There's a real difference between whether we follow a high emissions or a low emissions scenario. Another way to look at that, number of hot days in southern New Hampshire. We currently experience about 4 or 5 of these. Those are the hot, sticky days, greater than 9 degrees Fahrenheit. By the end of the century, under the high emissions scenario, we'd likely have something on the order of 50 to 60 of those, right? 2/3 of a summer as a heat wave, punctuated by slightly less uncomfortable days. Under low emission scenarios, we're still going to have 20 to 25 of those days, right? That's something that we're just going to have to get used to. You can look at precipitation as well, and this is a different story from temperature, because on precipitation, we don't see any real significant difference between a high emissions and a low emissions scenario. So let me just pause here for a second. And I don't often talk about benefits of climate change, but one of the things that New England will have in the future is fresh water. And there are going to be many places in the globe that do not have that fresh water. And you can look at what's happening in California and the Southwest right now as an example of that. So that's something that we should start thinking about. How are we going to maintain that precious resource, and one that will likely become more precious in the future? Unfortunately, more of that water is going to be falling in fewer events. So if you look at those 4-inch precipitation events and extend them out in the future, right, on average, southern New Hampshire had a little more than 4 per decade on the period from 1980 to 2009. Right, by the end of the century, lower high emission scenario, we see that tripling, doubling to tripling. Right, so as we develop our watersheds, we might want to think about ways that we allow more of that water into the ground, because we're going to have bigger events. Sorry, we're going to have more big events, and we don't want our communities to be flooding. And we have this historical record of actually settling on the coast and in river valley bottoms, so we're particularly vulnerable to flooding. And so that's going to be something that we really want to think about for our future communities. And last but not least, sea level rise. So this is a report that's available online. It was written by the Science and Technical Advisory Panel for the Coastal Risks and Hazards Commission. Say that 5 times fast. You can read all the details online, but here is the main point, right? Global sea levels have been rising and are expected to continue rising well beyond the end of the 21st century. Right? There is no uncertainty in that statement. Sea levels are going to continue to rise. The only range is really going to be like how much by when. But sea levels are going to be continuing to rise for centuries to come, and we better start getting used to that in terms of the way that we develop our coast. What the Coastal Risks and Hazards Commission asked us to do was actually provide a range of how much sort of the best science indicated that sea level could rise. And this comes right from the National Climate Assessment. So here's historic sea level rise, And that blue line is a straight line, a straight sort of linear projection through that. So that's not going to happen. When you hear people talk about, we don't have to worry about it, it's just going to do what it's done in the past. So that's not it. And it's because of what's happening to Greenland and Antarctica. So there's an intermediate low, intermediate high, and high projection. And this is going from 1.6 feet to 6.6 feet by the end of the century, right? A huge range. And more on the range of sort of 1.3 to 2 feet by 2050. So the reason there's such a large range, again, is we don't completely understand the dynamics of Greenland and West Antarctic ice sheet. And so we have to track those very carefully. There's lots of great research going on. We should have better answers in a decade or two, but we need to pay attention. On the other hand is we don't have to run out and do a whole bunch of stuff right away, right? We have time to figure out which one of those curves we're going to be on. But I would argue that actually we need to start thinking about that now because we can't wait till 2050 or 2080 to actually begin to spend the money on things that are going to protect our coast, right? We just won't have enough money in one single year. We need to start planning for the future now. And a big part of the Coastal Risks and Hazards Commission report, which you'll hear a little bit more about later, is that we need to keep checking back in with the science. What is the science telling us in terms of what we have to adapt to? So our major recommendation from the Science and Technology Advisory Panel is where there is little tolerance for risk, which means I'm not talking about the oyster shack, but I'm talking about significant infrastructure, wastewater treatment plants, schools, police stations, bridges, major access roads, right? Where there is little tolerance for risk, communities should commit to manage to 4 feet of sea level rise by 2100, but be flexible enough to be prepared to manage to 6.6 feet of sea level rise. I just want to provide a few maps on what this amount of sea level rise might mean for Portsmouth, New Hampshire. And for those of you that came in, Peter Britz was standing out front and he had a few of these maps. And he'll stand up later and talk a little bit about the work that they're doing in the city of Portsmouth. But I just wanted to share a couple of these. And I'm going to stand over here because it's much easier while you sort of orient yourself. So here I've got, this comes from this Coastal Risk Initiative. These are all available online at this website, so you can go and check these out on your own at any time. So here we're looking at flood depths with a pretty minimal storm surge, right? A 0.3 foot storm surge is nothing. That's a pretty small storm, but with 6.8 feet of sea level rise. So it's equivalent to 11.5 feet about NAVD 88. I predict in 5 years we're all going to know what that means, but it's a vertical datum that surveyors use, but essentially 7 feet above mean high water. So this is actually very much like the flooding we would expect from a 100-year storm today. The storm surge is about 7 to 8 feet. It's also would be the flooding. If we got 6.8 feet of sea level rise, this would be kind of daily high tide twice a day. Right? So it's a 100-year storm today. It's twice daily flooding with 6.8 or 7 feet of sea level rise. Same thing. And you can see that there's some pretty significant areas in the south end. All these little black squares are houses that are at risk of flooding, right? Old middle school, the new middle school's not here, library. And if you look at, you can ask Peter about this, so maybe this is an area that we might want to think about protecting. How would we do that? Maybe we put a gate up here and pump fresh water out during a big storm. That would cost a lot of money. That's something that we might want to start thinking about. You can also see that there's some areas around North Mill Pond that are at risk, and guess where we are right now. Another big piece that's a big cause for concern is Strawberry Bank as well, right? Used to be docks, got filled in, but you can see it's kind of in the bullseye. I will also say that look how high and dry the wastewater treatment plant is. All right, so you can do that same exercise. This time we're 18 feet above NAVD, 13.6 feet above mean high water. So this is kind of what we're looking at as a pretty catastrophic storm, end of the century, a lot of sea level rise. We're on the high range of the sea level rise with a really big storm. And you can see that the area that gets flooded is quite a bit larger. I should also mention, right, that what I'm showing here are flood depths on the land. 0 to 3 feet, 3 to 6 feet, 6 to 9 feet. Sorry, 0 to 3, 3 to 6, 6 to 9, 9 to 12 feet, right? So with this kind of storm, right, the water is up on the second floor of the houses in Strawberry Bank. Right down in here, the blue that we're having here, right? Tennis courts completely buried, just a lot of flood damage. And once again, this is something that's not going to happen, right, next year or the year after. We have time to think about this. But again, sort of this theme that's throughout my, my comments here is this is something we need to start having a serious discussion about. What is it that we're going to spend money on? What is it that we're going to save? What is it that we're going to let go? And that just provides you with a sort of a zoom in. And again, you can view all of those maps online. All right, I want everybody to take a really deep breath. Yeah. All right, it's going to be okay, at least for us. All right, so this is kind of the second part of what I want to talk about, and solutions with a question mark. I think there might be solutions. But again, what I've showed you up front first is the science, right? That's where I'm the technical expert in the science. I'm reporting out a lot of scientific information. Solutions are something that we need to have a community discussion around, but I want to sort of seed that discussion. I will also say at the outset that I mean, I've been here for 30 years, and New Hampshire has worn off on me, in that I don't think we should be looking to government to solve this problem for us. Government plays a very important role, and they will have a role, but this is too big a challenge to expect government to solve it all. It's going to take all of us acting at many different levels in society to solve that. So I really want you to leave tonight thinking about what you can do, your family, your community, your municipality, your state, and your federal government. So, as I said before, climate change is the innovation opportunity of the 21st century, but there's really kind of two buckets we think about. We have to reduce our greenhouse gas emissions, and we have to figure out how we adapt to the change that we've already committed to. So first and foremost, hopefully you've all heard about COP21, Conference of Parties. That's what came out of COP21 was the 2015 Paris Agreement on Climate Change, and this was a really big deal because it was the first time all of the countries in the world truly got together and said this is a global problem and we have to deal with it, right? 195 parties. They agreed to limit planetary warming to 2 degrees centigrade. There was this really strong lobbying from a group of people in the Marshall Islands and other islands around the world that said, that's not good enough. At 2 degrees, my culture disappears. I want you to shoot for 1.5 degrees. So 2 degrees centigrade is the target. 1.5 degrees is the aspiration. It was very different in that instead of there being a mandatory reduction for each country was allowed to make its own pledge on how much it would reduce greenhouse gas emissions. There's a system for measuring that's really important, and there is going to be this transfer of wealth from the more developed countries to the developing worlds to help them adapt and hopefully develop energy systems that don't emit carbon dioxide. But here's the rub from what happened in Paris. Here's what the greenhouse gas emissions are in 2014. And here's the various commitments, right? The US has agreed to reduce its greenhouse gas emissions. The European Union is going to reduce them. India is going to grow them. They didn't really play as nicely as other places. China's agreed to flatten out and reduce their emissions. But the pledges that we have out to 2030 are not enough to ensure that we don't get to 2 degrees centigrade. In fact, if you put those pledges forward, we're probably on sort of 3 degrees centigrade warming. That's the pledges now. So what was really good, we got pledges, and now all those pledges need to be ramped down if we are going to stick to a 2-degree warming world. But we have a world that wants to do on it, and there was a clear signal that was sent to financial markets is that this is an investment that's worth making. So if we want to stick to that 2 degrees centigrade target, here's the amount of fossil fuel that has to stay in the ground, that cannot be burned. 82% of our coal reserves, 49% of our gas reserves, 33% of our oil reserves, right? That needs to stay in the ground. You can see how that changes by different regions around the world, but that is really our challenge, right? Because companies have invested enormous amounts of money to identify those reserves, and they want to sell those reserves, and they can't. We need to figure out a different way forward. So there's actually some good news on that front. If you look at the annual global investment in renewable energy, we topped $285 billion last year from a whole range of private sources of money. To tackle the problem, we probably have to get that up to $1 trillion a year for the next 20 years. It's $1 trillion a year problem to invest in renewable energy. But we can take that money out of the fossil fuel industry and just invest it in the renewable energy industry. If you look, we actually crossed a really significant tipping point in 2015. Oh, I should go back and say, you know, in New England, we shouldn't really be too invested in fossil fuels anyway because it doesn't do us any good. Right? We just spend our money in fossil fuels and that money leaves our economy, doesn't create jobs. It's really not that good for us. Net generating capacity added globally in 2015, right? The first time that renewable has been bigger than anything else, even when you pull out large hydro. Right? This is a really big shift. We're now adding more energy generation capacity that's renewable than anything else, and that's just something that we have to continue out into the future. Coming closer to home, really important step in having the U.S. reduce its greenhouse gas emissions and move to more cleaner energy is the Clean Power Plan. It's a real game changer. The EPA finalized the rules last fall. I'm sure you've all heard there's a Supreme Court challenge that's sort of going to keep too much from going on quickly. Really proud to say that both of our senators, Ayotte and Shaheen, supported this. And New Hampshire and much of New England, and in fact the Northeast, is in pretty good shape because we've been doing this already because of the Regional Greenhouse Gas Initiative. So there's not a lot that we have to change in order to meet the targets because we've been cleaning up our act for about the past decade. Even closer to home, New Hampshire, we actually have a climate action plan. You can get it online. It's a great plan. And certainly worth reading. 67 recommendations that really focus on renewables and energy efficiency and preserving our existing ecosystem so they provide us with the services that we love. We try to annually sort of track how well the state of New Hampshire is doing in terms of reducing its greenhouse gas emissions. You'll see here the green line represents New Hampshire gross state product. You can see the flattening out that happened in the Great Recession, 08 and 09, but we're up around close to $70 billion. In 2013 adjusted dollars. But in 2004, 2005, just like the rest of the United States, we started dropping our greenhouse gas emissions. This is exactly what we have to do. We have to decouple economic growth from greenhouse gas emissions. You can see there's a somewhat worrying trend at the bottom here, but let's give that a couple of years to actually play itself out. All right, even closer to home, this is where I live. So, you know, as a climate scientist, what have I done to actually deal with this issue? Well, for a long time, I didn't do much, but I knew I wanted to do something. And so when my boiler died last summer, 2 summers ago, we actually looked into getting a wood pellet stove. You can see this beautiful, high-tech wood pellet stove in my basement. State of Maine gave me a rebate of $5,000. It cost me about twice what a regular boiler would, an oil boiler. But I expect to gain that back in 5 or 6 years because wood pellets, well, when we got it, wood pellets were half of what oil cost. Now they're about the same. I'll also tell you that it was one of the happiest days of my life when that stinky oil tank got taken out of my basement. We also have a heat pump water heater there that runs on electricity. We put in heat splits, so heat pumps on the outside to heat in the shoulder seasons and cool in the summer. This is how my pellets arrive. I put this here for Denise to show her that I don't have to carry big plastic bags. It actually comes in a big truck, and they just pour it into my basement, into this big box that I have, essentially, and it gets vacuum fed, so I don't really have to. It works kind of like oil. I don't have to worry about it. And then we are in the final throes of actually signing a contract to power our home. We have a duplex, our home and our neighbor's house, with solar panels up there on the left-hand side. So the point here is that renewable energy, if we space it over time and we install it when things need to be maintained or replaced, actually ends up being cost-effective in the long run. Energy efficiency in our homes is a really big deal. We really need to make them far more efficient than they have been in the past. I won't go into a lot more detail there. Another big innovation, I think, is how we might fund that. So, I've been a professor at UNH for a long time. I have some resources to fix my home, but not everybody has those resources to spend the 10 or 20 or $25,000 to make their home more energy efficient. So we have to figure out, and they are being figured out as we speak, innovative financing instruments that really help our communities become more energy efficient. Because when they spend less money on fossil fuel, they're going to spend more money on other things, and they're going to help our economy. Lots of great work going on in this front. Another activity that I think is really rather fascinating is this New Hampshire Coastal Risks and Hazards Commission that was set up by the state legislature to really begin to recommend legislation, rules, and other actions to prepare for projected sea level rise. And so you're going to hear a little bit about this later. We have developed a draft report that has a whole suite of recommendations in it that focus on our economy, our built environment, our natural resources, and our heritage. And it's open for comment now. And again, you'll hear more about that in a few minutes. But this is really essentially the beginning of that conversation that we need to have about what we want our coast to be like and how is it that we can ensure our communities remain vibrant into the 22nd century. Something else that you can do in your home if you are in an area or if your home is in an area that is at risk of flooding or has flooded quite a bit in the past is you can actually think about raising your home. So right now, I'm sure probably most of you know this, but flood insurance is really not covered by private insurers. They might sell it to you, but most flood insurance in this country is covered by the National Flood Insurance Program that's administered through FEMA. And so your flood insurance, essentially, because of a passage of a law back in 2012, the Flood Insurance Reform Act, that flood insurance is actually changing to reflect more of the risk. In fact, the flood insurance program is now $25 billion in debt. It was actually solvent in 2005 before Katrina hit, but after Katrina and Sandy, $25 billion in debt because those homes and businesses that got damaged weren't sort of covering the risk of the flood insurance that they received. So if you have a house that's at risk, your flood insurance, if it hasn't already gone up, it's going to go up in the not too distant future. So here's just a little diagram from FEMA. If your ground floor is below base flood elevation, that's the height of the 100-year flood, right? In a few years, if you're not already paying it on a $2,500 home, paying about $9,500 a year in flood insurance, right? That's a big ticket item. If you're 3 feet above base flood elevation, that goes down to $1,400 per year. And if you're 4 feet, $427 per year, right? It pays for itself even if you don't have the flood because your insurance goes way down. But if you do have the flood, it really pays for itself because you've been able to protect your home and keep that mold and that damage out. So again, something that for those of you that have homes at risk, something to really consider. We're coming down to the end here. I'm sort of on time. That's pretty good. City of Portsmouth actually really deserves to be commended for the work that it's done. And back in 2013, it actually commissioned this Coastal Resilience Initiative. That's where those maps that I showed you came from. And sort of lots of different ideas on how we might go about protecting the city from flooding in the future. There's 2 other opportunities for getting involved, the Portsmouth Master Plan and the Capital Improvement Plan. You'll hear more about the Master Plan afterwards. But I can't emphasize enough, right? This isn't about just the city's problem. This is about all of our problem. And if we really want to do it right, I think as many of us as possible can be engaged. This is sort of something I just heard about a couple of days ago, but something I'm really intrigued with. So bipartisan bill on accessory dwelling units. Right? Essentially, there's not enough affordable housing in the state of New Hampshire, and so a bipartisan bill that Governor Hassan signed that allows accessory dwelling units to be built. Every community needs to actually write up its own ordinances on how this is going to happen, but as our state grows, and as I think it will grow, even though sort of the demographers talk about lots of people leaving, when people realize we have fresh water, I think those migration patterns are going to change. I think there's going to be a lot more people coming to New England 10 to 20 to 30 years from now because we have water, and I think we need to be prepared for that. And this accessory dwelling unit allows sort of our existing built up areas to absorb those people. What we really don't want to do is cover all of our farmland and forest in houses so that we accommodate the people, but we lose those critical ecosystem services that provide us with food and water and areas to recreate, and sort of a big part of what makes New Hampshire a great place to live. So this is a great step forward. Getting very close to the end here. Another really important piece is preserving our, I sort of said preserving our land, but in particular our salt marshes. They are at particular risk from sea level rise, and there has been lots of land conservation around the region, and much of it focused in the coastal area. So one of my other sort of strong recommendations here is support your local land trust, whether that's the Southeast Land Trust, or the Kittery Land Trust, or the Nature Conservancy, or the Society for the Protection of New Hampshire Forests. They are preserving critical land that we need in the future to adapt to this problem. All right. So in closing, I started with this notion that climate change is a moral issue. And again, it's really those who are most vulnerable who are going to suffer the most. I talked about how that was Katrina. I talked about how that was young people. And I've mentioned that really there are people in island nations around the world that saying, why is it that I am going to lose my culture to support your standard of living? And it's a very powerful message. And it was made even more powerful by the Pope's encyclical on climate change. And if you haven't had a chance to read that, it is an amazing document and really worth a little bit of time to have a look at. So in closing, more than once, I have been called Dr. Doom. But I also love to dance. And that is the lens that I choose to look at this issue with. The storm clouds are gathering. In some cases, the storm clouds are here. And we need to learn how to dance in the rain. And I really look forward to having a discussion with all of you, in action with all of you, as we make Portsmouth and our Seacoast the most resilient place in the United States. Thank you. All right, so before we start Q&A, we just have 3 speakers who are going to come up and talk to you in a little bit more detail about activities that are ongoing. And the first one is Rick, right? I can't see. Rick Painter, planner from the City of Portsmouth. Lead planner?
Planning Director.
Planning Director.
Thanks. Very briefly, I feel like it's the commercial break here and everybody's going to run out to the kitchen. But if you are following our Facebook page, the Planning Department's Facebook page, which is Plan Portsmouth, you'll have seen that we have a preliminary draft of the master plan, which is now up on our website. Our website is planportsmouth.com. And if you go down to the lower left and look at plans and reports and click on the master plan page, you're able to download the current draft of the master plan. This is a very different master plan from any other plan we've done in the city before. It's instead of being kind of organized in the typical functional areas of housing, land use, transportation, et cetera, it's got 5 big themes. And if I can remember them, they are authentic, diverse, vibrant, connected, and resilient. And those are meant to essentially... Okay, we're done. But the plan is up there as a draft right now. We encourage you to download it and look at it and send us comments. We will be having some public participation, formal procedures happening sometime later this spring. We haven't actually set them up yet, but we will be reaching out to everybody and trying a number of different venues to encourage you to participate. But we welcome your comments. Please download the plan and share it with your friends and give us all your comments. And that's all.
Peter Britz, you want to come up next and share what else the City of Portsmouth is doing? I can't see anything from there. Oh, there he is.
Yeah, I just quickly want to say thanks for plugging the Coastal Resilience Initiative, and you can find it on planportsmouth.com also if you want to look at the maps that are outside or read the report or that kind of thing. You really can't see anybody out there, can you? But what I wanted to talk about quickly is the fact that one of the big recommendations and one of the findings of that study was that we look closer at our historic resources. One of the most vulnerable areas in the city is the South End and the historic homes we have and the historic museum and parks. So what we're going to do is we got some funding from the State Department of Historic Resources from the Hurricane Sandy mitigation money, and we're going to look closer at the south end, basically, and see where some of these more impacted homes are. Look closely at the prioritizing historic homes, and then looking at solutions to try to make ourselves more resilient in the future. And as part of that, we're going to have an advisory committee. So if you're interested in that or some of the work we're doing, contact me, and as that gets going, I can keep you in the loop about what's going on with that. So just wanted to make an announcement about that. Thanks, Cam.
And last but not least, we're going to hear from the New Hampshire Coastal Program on the Coastal Risks and Hazards Commission and how we're looking for feedback. And Kirsten's going to provide us with that.
Thanks, Cam. Hi, everybody. I'm Kirsten Howard. I work for the New Hampshire Department of Environmental Services Coastal Program. Along with my colleagues Natalie Morrison and Julie LeBranch, who are here, I've been helping to staff the Coastal Risk and Hazard Commission for the last 2.5 years or so. As you heard from Cam, the Commission released its draft report just over a week ago and is also looking for comments from stakeholders, coastal communities. So just to give you a quick background, the Commission was established in 2013 by the state legislature. They were charged with developing recommendations for legislation and for planning in the region, in the coastal region of New Hampshire. And this draft report that they released presents the science, the summary of the science. You heard a lot of that from Cam. It also begins to identify those vulnerabilities that we need to understand better in Portsmouth and other coastal communities, and points you to some of those resources like Portsmouth's Coastal Resilience Initiative that you can look to for more of that site-specific information that you need. And then lays out a series of guidance and tools and recommendations that essentially are intended to be a framework to help us have these discussions at the levels that they need to happen at, regionally, at the state level, in state agencies, and in municipalities, among stakeholder groups in the government, wherever that needs to happen. So we really hope everybody will take a look at that, and if you have ideas, if you think something's missing, if you just want to provide some comment and your thoughts on it, please do. I have flyers here that I'll pass around when I get back down that provide you with the link to read the report, provide you with the information you need to submit comments by email or mail or by phone. And then we're also having 2 public meetings in May and June that you can attend and engage in more of a discussion to provide your input that way. Thanks very much.
All right, now on to the part I'm sure you've all been waiting for. I think I've earned that beer. I don't know who's buying me one, but I'm hoping somebody will. All right, I'm going to move out away from the microphone so I can see you.
Turn that off.
All right, who's got questions? Sir.
In considering the
Actually, I think we have a microphone.
If you're in the middle of the row, I'll pass you the mic, but please pass it back.
in considering the sea rise as a consequence of the ice melt, why is it always described in terms of the Arctic ice sheet and no mention is ever made of the Antarctic ice?
So I guess I did Antarctica, a little short shrift as well. Oh, beautiful. Thank you. Now we're talking. So it's really both. We're seeing dramatic change in both the Greenland ice sheet and the western part of the Antarctic ice sheet, which is called the West Antarctic ice sheet. And in fact, both of them are significant concern. So on the West Antarctic ice sheet, there's these 2 glaciers called the Pine and the Thwaites Glacier, which are behaving just like Jakobshavn is. They're speeding up. They're transferring much, 2 to 3 times more ice into the ocean. Their ice tongues have retreated dramatically. And there's really particular concern about West Antarctica because most of it is below sea level. So there is the worry that the ice sheet would retreat far enough so that water could get in underneath it, lift the whole thing up, and ship it out to sea. So they're both a concern, and in the scientific literature, they certainly are both referred to. And the West Antarctica and Greenland have about the same amount of equivalent sea level rise, about around sort of 20 feet of sea level rise in each of them. So they're both a concern. And that's kind of over 50 to 200 year time scales. We're worried about the stability of those two. In fact, there was a paper that just came out this past week from Jim Hansen, Eric Rigno, and a number of other well-respected climate scientists that suggests that it might be happening faster than we think it is going to happen, and that, again, that it might be inevitable that they are going to disappear. It's just by when is the big question.
So I was looking at the graph that you pulled up originally that showed the carbon levels and the temperature and the positive correlation between that. And it made me think of this article I read this summer, which was talking about how it suggested that there's a limit to the effect of carbon on the greenhouse effect, and that once carbon levels reach a certain level, there's only so much that it can affect temperature rise. And I was just wondering if you think there's validity to that, and what your thoughts are on that.
So that's a really good question and a very sophisticated question. So when carbon dioxide is at relatively low levels, let's say 100 or 200 parts per million, adding 1 or 2 carbon dioxide molecules will have a bigger impact than if you're at 400 parts per million by volume. But it's also been something that a lot of naysayers have actually grabbed onto and said, we don't have to worry about it, there's enough carbon. And so what's actually happening is the radiation band over which carbon dioxide absorbs energy actually has fuzzy boundaries, and those fuzzy boundaries get wider with more and more carbon dioxide. So it's the effect is absolutely accounted for in the climate models. And it's not that it stops having an impact, it's the amount of impact is reduced, but it continues to be a significant impact. That does give me the opportunity to talk about nasty surprises, though. And so you think about that maybe as a little bit of a negative feedback, but not really. It's going to keep warming the planet as we put more carbon dioxide into the atmosphere. And we know, for example, there was this period back in time, 56 million years ago, called the Paleocene-Eocene thermal maximum, when carbon dioxide went way up in the atmosphere and temperatures were 4 to 5 degrees centigrade warmer for hundreds of thousands of years, and actually mammals evolved to be very small. So we see this in the fossil record. But one of the nasty surprises is we know there's a lot of carbon that's stored in permafrost and on continental shelves in these things called clathrates. So methane is actually stored in the crystal structure in the sediment of the frozen water. And during the Paleocene-Eocene thermal maximum, our best understanding is that increased carbon in the atmosphere came from melting permafrost and ice shelves. And so if we pass a tipping point where we melt, our permafrost melts and our clathrates melt, there's really nothing we're going to be able to do to keep the planet cool. So that's we call that a positive feedback loop. You might consider it a vicious cycle that we really want to stay away from. Excellent question. Who's next?
So Cam, you and I know one another. I'm going to say hi to everybody here. I'm Wes Tater. I'm a resident here in town, and I have the good fortune to be part of a group called Citizens Climate Lobby. And my question to you, Cam, and I know you've talked about fees on carbon, and I'm wondering if you'd be willing to reconsider your position about government, to include government. I'm of the opinion that there's room for us all, and in fact, we need to be looking at putting a fee on carbon at the federal level. Now, my particular perspective is that those fees come back to citizens. But what do you think about including the federal government and putting fees on carbon?
So this is a chance for me to clarify. I didn't say government wasn't important. I didn't say we should rely solely on government. Right, Martha, you heard that, right? Thank you. And so I just hear people saying, they need to do this, they need to do that. I want us to say we need to do this. And so, yes, actually, I think the most important thing that the federal government can do is put a price on carbon. And it has to happen in order to make renewables far more attractive. And in fact, I would argue that we should just get rid of all subsidies for energy, and let's just go with the one that makes the most economic sense after we put a price on carbon.
Great.
So,
And here's where the we comes in. Government responds to us when we write to our senators, when we write to our representatives, when we stand up and say the time has come to put a fee on carbon. That's when it'll happen. It's not happened before then.
And I would add that Wes said something very important at the beginning, is that this is not about bigger government, right? The carbon fee should be, in my humble opinion, revenue neutral, so that you actually tax carbon, energy, right, from fossil fuels, but you use that so you can give it back to people. You can reduce all kinds of other taxes because it would create an enormous amount of money. So it's not about giving more money to the federal government so they can come help us solve the problem, right? It's about sending a signal in the marketplace so that all of us do the right thing and that we're not paying more taxes and solve the problem. And it's a really elegant solution, and it needs to happen soon. Yes, sir.
Over here.
Oh, I'm not picking anymore. I'm not in charge.
Thank you. I just had one quick question. At what point do we need to be concerned more than we already are about the Seabrook nuclear facility?
So that's a great question. What's the lifetime on Seabrook? Do we know?
Hopefully 2030. License expires.
Hopefully 2030. And then if they want, they might get a 20-year extension on that.
Right.
Right. So 2050. So so let me just preface this with, I am not a nuclear engineer and I don't know that much about nuclear energy. Right. I do live across from the Portsmouth Naval Shipyard, where I know they store some nuclear waste. So there's some concern on my part. But if you look at the sea level rise maps, they are actually high enough in that even in one of the really big storms at the end of the century, it's unlikely that, they're not going to have waves topping over the ground at the Seabrook nuclear power plant. So from that sort of frame of sea level rise and climate change and the lifetime of the plant, I think we're in reasonable shape. I think there's some other concerns that I just don't know that much about in terms of where is the waste stored? Is it below ground? Where are the generators that have to run in case we do have a big storm and they got flooded because of really heavy rain? Are they high enough so that they don't get flooded, which is what happened at Fukushima? So I guess I'm not the technical expert to answer those questions, but purely from a sea level rise, big storm, there is going to be a lot of other, let's call it billions of dollars of damage on the New Hampshire Seacoast before the Seabrook power plant ever floods. In the near-term future. Right, let's get that time period on there.
Here we go.
Hey, Cam, Allison Pyatt, how are you? Great. I'm back here. You mentioned the appropriate role of government, and you've talked a lot about the role of individuals and families, but what is your opinion on the role of corporations in business? And then, of course, I have to ask the role of investment portfolios in driving that change.
Oh, thank you for teeing that up, Allison. And I should have included businesses in that frame, but I think they play an incredible role in moving us forward in many different ways. But let's pick on the investment first. I think we need to start thinking about how we invest in our future. And that future is not one that's fossil fuels. You saw that graph about how much fossil fuel needs to stay in the ground. And so I think a big part of those investments need to be in what are the new sources of energy, but then how can we make all of our other processing, manufacturing much more energy efficient, and eventually we're really going to have to get to closed loop, right? We're just going to have to we're just going to keep using those raw materials, and we have to figure out a much better way to do that. I think corporate America has an incredibly important role to play. And you can see that there are definitely those companies that are taking a stand and making a difference. And I think that leadership is critical, and I'm hoping in the not too distant future that the Chamber of Commerce sort of nationally can come around on this issue as well. Perhaps most importantly, the fight right now is around the Clean Power Plan. Really important that we get that passed and get that start acting on that. I don't know if I answered your question, Allison, but I tried.
Hey, Kim, Dave Cohen here. A quick one, pulling back to the global perspective. I'm curious what your thoughts are, on developing nations, China and India in particular. From what I can glean from the mainstream media, we've got a couple things going on at once. We've got a lot of coal burning and fossil fuel burning as those economies develop. At the same time, they seem to be aware of alternative technologies as well. What are your thoughts on those nations in particular and their balances from a political perspective on the importance of the issue and how they fall on that?
So I think what came out of Paris that was really interesting, Dave, was that you saw this split in the developing world. So China and America cut a deal beforehand. China's going to flatten out its emissions by 2030, while the U.S. is going to reduce its emissions. So China is fully aware of the problem, and in fact, if you look at countries that are at risk from sea level rise, China has by far the most to lose in terms of number of people who would be affected. And so China has taken on this leadership role, right? Now the largest producer of solar panels. At the same time, they are still building lots of coal-fired power plants. But they are mapping out a future where they're going to stop growing their emissions. And they are now leading the developed world in that effort, and that's really important. India's on the other end of the spectrum. We still have to raise the standard of living of our people by any means possible until we can begin thinking about reducing greenhouse gas emissions. And so India, I think, is a really tough nut to crack, but they were kind of the big reticent country in Paris. They signed on. That was good, but a lot more work to do there. For here, Dad. Oh.
Next, Mark.
So I had a question about some cities, say New York City after Sandy, are doing planning that's really dealing more with the storm surge. And what I think you've been showing us this evening is that that's out there, but there's also just a larger trend. What do you see as the differences between those, sort of event-based planning versus long-term trends?
So I think the big damage really comes with the big storm surge that happens at high tide on top of an amount of sea level rise. So that gets everybody's attention. But the day-to-day inundation, it's called nuisance flooding in some areas, like any flooding's a nuisance. It's becoming a really big issue in Miami, right? There's streets you can't drive down twice a day because the tide's too high. So I think they're both important, but the big driver here, I would say, is we really have to think about how we deal with those big events. And if we do that, we're actually going to be dealing with the more sort of the day-to-day trouble. And in terms of long-term trends, what we want to do is really ensure, we need to work hard so we don't have 30 to 40 feet of sea level rise, because that becomes a completely different world. And there's scientists that are saying that is inevitable. I'm not being alarmist. I am telling you what the science is saying. And so, but the question again is, how quickly will that happen? If you read Jim Hanson's paper, he says, maybe this century, but most likely within 200 years. And so given that, as global population goes from 7 billion to 9 billion, we're going to be building a whole bunch more infrastructure. We might want to think very seriously about where that infrastructure goes if we want it to last more than 20 years. So I think that the long term, the trends are a real challenge when you add them to the big storm events.
Hi, Kim.
Collis Stoll. We met at MIT Sea Grant a couple of years ago, the symposium on climate change. And at the time, I think I told you that I was going to start a nonprofit to bring the sustainable seafood message into middle and high school classrooms. One of the dances that I find myself doing is walking the line between informing students about the implications of climate change. We talk about, for example, the Gulf of Maine warming almost 0.5 degrees a year for the past decade, and that, the implications that has. So between that and scaring the hell out of them. And so it sort of raises a question, back at the MIT symposium, the bracket for sea level rise is 1 to 4 feet. And now we're looking at 1 to 6.5. So I guess my question to you is, how confident are you that even, as in the next decade, when we start to learn more about ice sheet melting, that we're still going to have a good handle on how to deal with it, and how do we convey that message, I guess?
So I guess if there's one thing I'm confident in, and this is not my particular area of science, although I was trained formally as a glaciologist, so I do understand it a little, is that there's tremendous resources being poured into really trying to understand the dynamics of these large ice sheets. So I would say I'm pretty confident that 5 to 10 years from now, we're going to have a better idea of how quickly these large ice sheets can collapse. And the real challenge for science on this is that we have never seen this happen, right? We weren't around we weren't studying big ice sheets 18,000 years ago when the Laurentide ice sheet collapsed. But it collapsed really quickly over a matter of a few thousand years, and it was much bigger than what Greenland and Antarctica are today. So it's a really challenging problem because of the physics, and if you really want the details, it's the physics of an ice cliff that's 400 to 600 feet vertical after the ice tongue has gone. How fast does that collapse as you have warm water lapping up against it, and how fast does it go back? And that's what a lot of the effort is on right now, and I think we're going to have a better sense in 10 years. I'm not confident that it might not be really bad news.
Thanks, Cam, very much. I wanted to ask you about the issue right now that we're dealing with is renewables versus fossil fuels. And we're seeing, a shift moving away from coal, moving away from oil. And people here know that we're in the process of trying to close down those oil plants, those coal plants in New Hampshire. But what we're seeing instead is a sense that natural gas is a safe alternative, and a lot of push to bring more natural gas to New England because there's concern about our very high energy costs. And I'm wondering if you could talk a little bit about what is the risk that is involved with expanding natural gas, and how do we incentivize greater investment in renewables?
All right, thank you, Martha. I'll take a stab at your first question. The second one, maybe we can ask one of our financiers to explain a little bit more, but I definitely think it needs to happen. So I think at best, natural gas is a stopgap measure to get us off coal and oil and a transition to something renewables. So the risk there is that we invest all this money in the pipelines. We've seen this with big coal-fired power plants, and my particular issue is the scrubbers that we put on Bow Station to the tune of $450 million. That is now a stranded cost, and we're never going to get that back. So I know pipelines aren't going to cost as much, but the risk is we put all of this energy into natural gas, which again is still imported into the region. It's not really doing great in terms of enhancing our economy because we're paying for it from outside the region. And so that slows the growth of renewables. Perhaps a little bit more sinister is, and there's good science and there's emerging science on this, is that we are emitting a lot of natural gas to the atmosphere from leaking fracking wells and leaking pipelines. And I was talking to Selena the other day, I just don't get it. It's profit that they're letting go up into the atmosphere that's really bad for us, but it's profit. Can't we build pipelines so they don't leak or wells? But we know that it's increasing in the atmosphere really quickly because we're measuring it all over the world. And so recently, one of the estimates I heard was that natural gas, when you consider all of the leaking that's happening and the fact that methane is a much more powerful natural gas, is actually no better than coal. So I read that, I heard it, I haven't researched it, but the risk is, on the bigger risk is that if we go down the natural gas, it's going to be just as bad as coal has been. And so I think your follow-up question is exactly right. How is it that we get that investment into renewable energy? We have seen exponential growth in the solar market. You've been fighting the good fight up in Concord. I think we really need to sort of not have these limits on net metering. I think every home should be its own power source, much more secure. And maybe Allison can tell us about the financial instruments, but I think we have to expand those financial instruments so it's not only sort of big investment companies and big banks, but really all of us. If I want to invest my money in something that's going to make money, why do I need to put it in a stock market and send it up smokestacks in China? Why can't I invest that in my community at low risk and have a reasonable rate of return? And the Community Loan Fund is doing some of that, and they're doing wonderful work. Jordan Institute is doing some of that, but we need more of that so that our investment dollars can work twice for us, both in terms of the interest we get and the change that we want to see. Anybody want to comment on the financial investments that we need?
Yes. So it's pretty straightforward that a fee on carbon, a tax on carbon, if you will, becomes a signal to the private sector, and business will respond accordingly. Once there's some certainty, they are incentivized. There's a lot of creativity in our economy, but when it's regulatory and it can go out of existence easily, not so much enthusiasm. Thank you. Here we go. Question back there.
Yes, maybe a little simplistic, but to what extent does increasing the plant material in the world, like as in the northern climes, as they get a little bit warmer here, mitigate the carbon emissions?
So I'm getting well outside of my area of expertise of glaciers, especially when we start talking about biology. But clearly, big ecosystems can serve as an important sink. It's not enough. It's not taking up enough now. It's probably taking up about a third, maybe a little bit less of the anthropogenic carbon that we're putting into the atmosphere. It's taking up way more, but the additional piece. So in fact, growing especially forests around the world is a really good idea to act as a carbon sink. And the other cool thing about forests is they provide all these other fantastic services for us, like wood for timber and wood for energy, and they clean our water and they clean our air and they provide spiritual rejuvenation. So all those are very good reasons to sort of allow those ecosystems to grow. And in many ways, New England is the success story, right? We were approximately 50% deforested, 150 years ago. And we've now reforested. While much of the rest of the world has seen big deforestation, we've actually increased the amount of carbon that's stored on the land. So it's certainly possible, and I would say it's a really important piece of the bigger puzzle.
Okay, just a couple more questions here.
Hi there, I'm Steve Diamond with the Making Waves show with Portsmouth Community Radio. I applaud you for emphasizing that the government can't fix everything, but I hope we will all hold, especially the federal government, to account on not making it significantly worse. In my mind, two of the factors that make it significantly worse are the trends toward free trade, of moving things all over the world to make them in places like China, where a lot of their production is to serve our needs. And I would also say the alliance with Saudi Arabia, which is pumping like there's no tomorrow, is a problem. Do you have any comment on that?
So I'll comment on your first one, and I actually did a little bit of research into this notion of food miles. And it turns out that it's not nearly as big a deal as we might think it is. There's a pretty famous paper now that came out of Carnegie Mellon that suggested that sort of in terms of a carbon footprint, transporting food, sort of had an impact of around 10 to 12% on the carbon footprint. Not a lot more than that. I think there's a whole bunch of other reasons why we should eat local food, like it tastes better and it's good for our economy and it's way fresher and it's got more nutrients and it's better for you, and like what else do you need to say, right? It's better food. But the food miles one is not a convincing perspective when you do the detailed analysis. So I guess I'm not convinced that free trade is necessarily a bad thing. I think it could be. But not necessarily. I think we should grow way more of our food locally, but not because of the carbon footprint associated with it. And then in terms of Saudi Arabia, we just have to, I think we need to be very serious about raising our energy security. And we do that by becoming twice as efficient as we are now, which Germany is, so we can do it. And what energy we need, we just generate locally. And we can actually do it with the technologies that we have today. So you can go down the regulatory free trade realm, or you can just say, we don't need your fossil fuel. And what's going to happen is what happened sort of the last couple of years, is that when you decrease demand, fossil fuel's not worth much, and people start pulling it out of the tar sands and drilling it in the North Sea because it's just not worth a lot.
So Cam, do you have anything to say about the...
Hold it. You got to control this crowd.
So I'm a groundwater scientist, and I recently was at a conference at Plymouth State University where I saw the work of a UNH doctoral student who had done some extensive modeling of the Seacoast area. I was wondering if you're familiar with her work, which showed groundwater levels rising on the order of 3 to 4 feet, in addition, as an influence or as a result of sea level rise, and that did not incorporate additional precipitation that's been modeled by the global climate models. And I was hoping you would comment on that as something that we need to consider about our infrastructure, as well as surface water flooding.
So great question. And I think it was Jane, right? Jane Knott, who's doing the groundwater modeling, and she's come and has spoken to the Coastal Adaptation Work Group that I'm a part of. And so essentially what the concern here is, and this is pretty innovative modeling, is that as you raise sea level, especially on a coastal area or in a big peninsula, which sort of Portsmouth and Newington is, if you think about Great Bay, right, you get that groundwater intrusion, the saltwater intrusion, and that pushes the groundwater up. And it turns out that the research I've seen her present was kind of shocking, right? A increase in the level of the groundwater by 3 to 4 feet, which the study that I saw that she was working on was out at Pease, and it shows roads regularly flooding out there. So I think it's an emerging area of research. I'm hoping she's going to publish the papers soon, and I would say it's absolutely something that we need to consider. I will say that when the city was having the debate about the wastewater treatment plant, nobody seemed to think that nobody had heard about that happening out at Pease, that there was going to be this significant groundwater issue out there. And in some cases, I don't know if the engineers in the town of Portsmouth dealt with that issue, but certainly one that's going to be an issue for, what is our big area to expand our industrial complex in the future.
Okay, I think we have to call it there. Thank you, Cameron. That was great. So there was a lot to digest here. If you want to review it, it'll be on video on ps21.info, and there'll be other information there about climate change. Thank you all for coming.